Hi everyone. So now let's start discrete random variable, which is one of the most important topic in this probability distribution, right? Okay. So the first definition that we are going to study in discrete random variable is probability mass function. Let's just see this definition. What is this probability mass function, or sometimes we call it in short PMF, probability mass function. So although I have used this term here and there, like in previous lectures also, but this is the first time we are defining it properly. So what this probability mass function says that if we are listing down the probability of each value of the discrete random variable, then it is called probability mass function. Let me give you one example. Like for example, suppose I have a discrete random variable x, which is saying x is basically saying number of heads in a flip. Okay, you can define anything. Like let's suppose the experiment is basically flipping. So suppose there is an experiment which is so there is an experiment which is saying that you are flipping the coin. So the experiment looks like this. Flipping the coin once. Okay, just once. Now in that case, if I say that x is number of heads in a flip, now tell me first what are the possible values x can take. Either on the flip there will be head or there will be tail. So you will say the possible values of x will be either 0 or 1. So there are two possible values, right? So let me list down all the possible values of x. So either x will be 0 or you will say or x will be 1. So these are the two possible values. X is 0 or x is 1. Now tell me when this x will be 0, whenever you have tail, and when this x will be 1, whenever you have a head. It is as good as saying that in the sample space, if you have head and tail, then it is getting mapped to 1 via x and getting mapped to 0 via x. This tail is getting mapped to 0 via x. Now what are these probabilities of x being 0 and x being 1? Obviously 1 by 2, 1 by 2. Why? Because x is 0 whenever there is a tail, x is 1 whenever there is a head. So the probabilities are 1 by 2, 1 by 2. So you have now your PMF ready, which means that if you have probabilities for all the values of x, then this is called probability mass function. Now you are saying you have the probabilities for all the values of x, right? For x equal to 0 also, for x equal to 1 also. Then this is called probability mass function. See, listing the probability of each value of the discrete random variable is called probability mass function, which is PMF. Right? Now let me give you more examples. But before that, obviously one thing you can observe is that summation of all the probabilities should be always 1. Summation of all probabilities should always be 1, right? Okay. Now let's just do this question. Suppose that a coin is tossed twice. Now we are tossing the coin twice, and let x represent number of heads that can come up. So if we are tossing it twice, now x is number of heads that can come up. Okay, and represent number of heads that can come up. So if you're tossing it twice, then number of heads could be in the complete experiment could be 0, maybe tail, could be 1, could be 2, right? See, the sample space looks like this: head, tail, head, and tail, right? Now for head, I will say number of heads are 2 here, number of heads are 1 here, number of heads are 1 here, number of heads are 0. So basically x can take these possible values only. Now if I just ask you the probabilities for each associated value, see, x can take 0, 1, 2, right? Now if I just ask you the probabilities for 0, probabilities for 1, and the probability for 2, then you will say probability for 0 will be like each is having 1 by 4 probability, so this will be 1 by 4. Why? Because 0 will be there whenever you have tail. 1 will be there whenever you have these two possibilities, which means the probability is 2 by 4, or you can say 1 by 2, right? Now similarly, this 2 will be there whenever this possibility is there, then the probability is 1 by 2. 1 by 4. So the probabilities here for x equal to 0, 1, 2, see, these are the possible values, and for 0, 1, 2 the probabilities are 1 by 4, 1 by 2, and 1 by 4. You can cross check it that the summation should be 1. So that's how you can solve this question. What is this? This is your PMF of x. Why I am calling it PMF? Because this is the all possible values of x, and you have answer for all possible values. Answer means you have the probabilities for all possible values of x. That's why we are calling it PMF, probability mass function. Okay. Now let's just go to the second question. What they are saying, check whether the function given by this particular example is valid PMF of random variable x or not. So this function, whatever the function is given, now let's just check whether it is a valid PMF or not. Okay, so how to check whether it is a valid PMF or not? So every of the probability should be greater than or equal to 0, obviously, right? And the summation of the probability should be 1. So let's just check, which means the possible values for x will be 1, 2, 3, 4, 5. So let me just check whether probability of x equal to 1 plus probability of x equal to 2 plus probability of x being 3 plus probability of x being 4 plus probability of x being 5, whether all of this is 1 or not, right? Whether all of this is 1. Let's just check it. Now how to check it? See what you need to do. See here, this is x equal to 1, right? Now you need to put x equal to 1 here, small x equal to 1, I mean this is 1, and then you will get the probability. This is 3 by 25, I think. You put 2 here, this will be 4 by 25. You put 3 here, it will be 5 by 25. It will be 6 by 25, 7 by 25, yeah. So if you sum all of this, then you will see that it is 25 by 25, which is just 1, right? 7 plus 6 is 13 plus 5, 18 plus 4, 22 plus 3, 25, right? So this is 25 by 25, which is just 1. I hope that is fine to every one of you. So what we are doing here, we are basically summing up all the probabilities. We are summing up all the probabilities, and then this is coming out to be 1. Okay. Now let's see this question number 3. Suppose that a pair of fair dice are to be tossed. Now in this question they are saying the experiment is such that you are tossing a pair of fair dice, and let the random variable x denote the sum of the points. So there are two fair dice, okay, that you are tossing, and the random variable x sum of the points that are appearing. So what are the possible values of x? Can x take 0? No. Can x take 1? No. Summation cannot be 1, right? At least if 1 is there on the dice, if this dice is, let's suppose, having 1, this dice is also having 1. If 1 is there on the dice, then in that case you will say that the summation is 2, not 1, right? So that is why the summation is at least 2. So it could be 2, and till 12 it can be, right? Because 6 and 6 will give you 12. So summation, it can be 3, it can be 4, it can be 5, it can be 6, it can be 7, it can be 8, it can be 9, it can be 10, it can be 11, it can be 12, right? So I hope that is fine to everyone, that these are the possible values that x can take. Now let's just check if we can have the probabilities here also or not. So what is the probability that x will be taking 2? When is x2? Whenever you are having 1, 1, isn't it? And see, there are different possibilities. Maybe I can go to the next page. There are many possibilities. I think there are 36 possibilities, and each of them is having equal probability. So everyone is having 1 by 36 probability, right? Okay. So let me just go to the next page here. Now when is x2? Whenever you will say that 1 is appearing, and this is having the probability of 1 by 36. So basically probability of x being 2 is same as probability of 1, appearing, which is basically 1 by 36 probability, right? So that is why you will say here you are having the probability of 1 by 36. What about this probability, x being 3? X will be 3 whenever you have 1, 2 or 2, 1. That's why 2 by 36 probability, right? X will be 4 whenever you have 1, 3, and let's not worry about the permutation. I will consider it in a while. And then 2, 2, right? And then 3, 1. Okay, so these two possibilities, and 2 into 2. Why? Because you can have 1, 3 or 3, 1 or 2, 2. No, 1, 3 and 3, 1 you can have. So these are the two possibilities associated with this, but this is just one possibility. So I think 3 by 36, right? Okay. What about x being 5? I think you can have 5 by 1, 4, 2, 3, 3, 2 it will come. Okay, so there are two possibilities here. There are two possibilities here, either 1, 4 or 4, 1, or 2, 3 or 3, 2. So that's why 4 by 36 will be the probability, x being 5. What is the probability that x is 6? You can say x is 6 when 1, 5 will come, 2, 4 will come, 3, 3 will come, right? Okay, so these are the 2, 4 possibilities, and this is 5. So 5 by 36, right? So this is 1 by 36, 2 by 36, 3 by 36, 4 by 36, and 5 by 36. What is the probability x being 7? I think 1, 6, 2, 4, 3, 2 comma 5, 3 comma 4, and then 4 comma something, right? So this is having 2, this is having 2, this is having 2. So 6 by 36. Okay, so these are the probabilities. Now let's just see if the pattern is same or something is breaking, which means 1 2 3 4 5 6. Do I have 7 possibilities for x being 8? X will be 8 whenever you have 1 comma, okay, for with 1 you can't have anything, so you have to have 2 comma 6, 3 comma 5, 4 comma 4, right? And then 5 comma 3. Okay, so 4 possibilities here, and 2 and 2, 4 possibility, and this is 1. Again 5 by 36. Okay, this is not increasing in that way, so then it is 5 by 36. Okay, cool. And what about 9? For 9 I think we have 1 comma 8 we can't have, 2 comma 7 we can't have, okay, 3 comma 6, and then 4 comma 5, and then I think it will repeat 5 comma 4, right? So this is 2 possibilities, this is 2 possibilities, so again 4 possibilities. Okay, it started decreasing, so 5 6 and then 5 4 again, right? So you can check it out. It will be 3 by 36, it will be 2 by 36, it will be 1 by 36, right? Okay, just to verify, let me just check if the summation is 1 or not. 1 plus 2 3 and 3 6 and 4 10 15 21 26 30 33 35 and 1 36. Yes, so summation is 36, which means 36 by 36 is the correct answer. Why? Because it should be 1, and 36 by 36 is 1. So these are all the probabilities that x can have. Now what we call it? We call it probability mass function. This is probability mass function for x. Why? Because for all the possible values I have the answer, right? Okay, now let's just see the answer. 1 2 3 4 5 6, and then at 8 it is again 5 by 36, right? At 8, yeah, that is correct. Now what we are actually doing, okay, just to calculate this PMF, what we are doing, we are writing all the possible values of x, and then we are seeing that how many outcomes are leading to this possible value. Like in this case for x equal to 4, I think 1 3 is leading, 2 comma 2 is leading, and 3 comma 1 is leading. So 3 outcomes are leading, so that's why you will say that the probability is 3 by 36. So basically you're collecting all the outcomes which are leading to this, right? Similarly, for x equal to 12, you will say 6 comma 6 is leading to x equal to 12. So what you are doing, you are collecting all the outcomes. So for x equal to 10, you will say, I think 5 comma 5 and 6 comma 4 and 4 comma 6. So these 3 are leading to x equal to 10. So you are collecting all the outcomes which are leading to x equal to 10. So you can say, if you want to find out the PMF, then what you can do, the first thing that you have to do is collect all the possible outcomes that give rise to the event x equal to particular that value, x equal to 1, x equal to 2, x equal to 3, x equal to 4, something like that, right? So you will collect all the possible values, add their probabilities to obtain. Okay, some people write in that way, otherwise like you can this notation and this notation same. Okay, some people like to write in that way. So this is a screenshot that I have taken from MIT book. Cool. I hope you understood. Anyway, this is optional. You do not need to understand if you have not understood. That's completely fine. I mean, it is just saying that collect all the possible outcomes and add their probabilities to get this probability, right? Okay. Now let's just see this question. What this question is saying, the random variable x has a probability function which is looking like this, where k is constant. Now they're asking you to find the value of k. This is what they are saying. So how to solve this kind of question? See, they have one unknown which is k, and they're asking you to find the value of k. What you can do, you can add all the probabilities, probability of x being 1 plus probability of x being 2 plus probability of x being 3 plus probability of x being 5, sorry, x being 4 and x being 5, right? These all probabilities should be 1. These all probabilities should be 1. So probability of x being 1 is basically kx. So this is, if you put x equal to 1 here, it will be just k, right? So this is k plus 2k plus, if you put x equal to 3 here, this is again k plus 2k plus 3k, right? This should be 1. So if you add all of this is 5 6 7 8 9. So from here you can say k equal to 1 by 9, right? K is 1 by 9. Okay, good. Now let's just see the next question. So what this question is saying, suppose that b and c are the discrete random variables, each is taking value 1 2 3 with a joint probability mass function p bc, which is given with the following table. So they are saying that each of this probability is basically joint probability distribution, which means they are saying the probability of B being 1 and probability of C being 2, this probability is given to us, which is 2 by 20. That's what they are saying. The probability of this comma this is being like the joint probability of these two is coming out to be 2 by 20. That's what they are saying, right? Okay. So here if you have understood this, now they are saying that one of the entry is missing, which means this entry is missing. Now they are saying determine the value of the missing entry, which is P33. That's what they are asking. So can you just try solving this question? See what is happening here. These are the won't all of this will combinedly give you the complete sample space or the partition of the sample space, which means the only possible values of B are 1 to 3 or C are 1 to 3. So if I just add all of this possible values, then won't I say that if I just add B equal to, let's suppose K1, okay, okay, let's not go with the notation, otherwise you will get confused. So basically if I just say B equal to 1 comma C equal to 1 plus probability of B equal to 1 comma C equal to 2 plus probability of B equal to 1 comma C equal to 3 plus probability of B equal to 2. If I just add all of these probabilities, C equal to 1, all of these probabilities, won't it will give you 1? Okay, maybe I can go to the next page and I can just try explaining you again. See what I'm saying here is that if we have this particular table, okay, just tell me, okay, let's suppose this particular value may be K or something. Just tell me if you add up all of this, what is this? This is the probability of C being 1, isn't it? This is the probability if you add all of this. This is the probability of C being 2. This is the probability of C being 3, right? And once you have these probabilities, if you add all of this, then don't you know that if you add these three probabilities, because C can take only these three values, this should be the valid PMF, right? This should be the valid PMF of P of C, right? Then if you add all of these values, won't it will give you 1, right? So what we are doing essentially we are adding up all the entries and then we are saying it is 1. But actually, see, you can understand with this probability distribution of probability mass function of P, but I want you to understand directly with just joint distribution. That with one random variable, if these are the possible values, then they will give you 1. If two random variables are there, and if these are the only possible values, then the summation of all of this the joint summation, okay, joint probability distribution of all of will give you 1, right? So either B is 1, and then see, if like it's like that. See, once you have B, so B equal to 1. Now you're just B equal to, either B can take 1 or B can take 2 or B can take 3. So you are saying that all of this probability combinedly will be 1. That's what you are saying because of valid PMF, right? Now what I'm doing here, I'm again for B equal to 1, I'm again having 3 possibilities. C for the C can be 1, C can be 2, C can be 3. So these are again 3 events, right? In this B equal to 1 that can happen. So what I'm saying that for B equal to 1, these are the 3 events. For B equal to 2, these are the 3 events. For B equal to 3, these are the 3 possible values that C can take. So why not I can say that this combinedly, all of this will just partition the sample space, right? So you will say that if I add all of this, then it should be 1. So if you add this is 1 plus 2, 3, 3, 6, 7, 8, 8, 9, 10 and 15 and then 16. So it will be 16 by 20 plus K. That should be 1. And then from here, K is coming out to be 1 minus 16 by 20, which is coming out to be 4 by 20, right? Which is 1 by 5 or 4 by 20. Let me just write 4 by 20 only. So that's how you can solve this question. Let me just see the answer. Yes, 4 by 20 is the answer, right? So the sum of the all entries should be 1. That's what they are saying. The sum of the all entries should be 1. Okay. Now, let's just do one question, which is little tricky, little tough to be honest. So what we can do, we can solve this question in the next video. I just want you to solve this question. This is honestly, this is little tricky, little tough question. So just try solving this question and then just find out what is the possible values of, what is the value of P, probability of X equal to Y. Okay. Let me just give you the options probably. Maybe one of the option is 1 upon n square, 2 upon n, another option is 1 upon n, another option is something like, okay, Once again, probability of y equal to 1 upon n. Suppose these are the 4 options A, B, C, D. Just solve this question and we will meet in the next video. Okay, this is honestly this is little tricky question, but you will enjoy this question. Okay, let's meet in the next video. Thank you so much.